If the shortest side in a 30, 60, 90 degree triangle is 1/2 inch long, find the length of the other two sides. Okay, so here's the picture they've given us, and we know from geometry and also from the reading, and I think it's section 2.2, that's in this reading, section 2.2, that a 30, 60, 90 degree triangle is a special kind of triangle. We know if we have a 30, 60, 90 triangle, so let's just draw one out here. So if we have a 30, 60, and 90 degrees, that's what this little box here just means, 90 degrees. If we have a 30, 60, 90 degree triangle, it's a special case if this side is 1, then we know the hypotenuse is going to be 2, and this is going to be the square root of 3, the other side here. And we can prove this to ourselves because we can say we know the Pythagorean theorem is a squared plus b squared is equal to c squared. So if we say the short side here, a is equal to 1, b, the other middle side is equal to square root of 3, and then c, the hypotenuse there, would have to be equal to 2, because hypotenuse is from the largest angle, which is 90 degrees here. 90 degrees. Okay, so let's just check this. So this would be a squared is equal to 1 squared plus b squared, which would be the square root of 3, quantity squared. Does that equal c squared or 2 squared? Well, 1 squared is 1 plus square root of 3 squared is equal to 3. Does that equal to 2 square root of 4? Well, yeah, 4 does equal 4. So we know this is proof that this is true. If the shortest side is equal to 1, then we know the hypotenuse is equal to 2, and the other side is equal to square root of 3. And the way I remember that is we know it's 1, 2, square root of 3. 1, 2, square root of 3. And square root of 3 is a little bit smaller than 2, so therefore we know it's going to be the middle size there. Okay, so now we know all that. Let's jump into the problem here. Well, if this side over here, if our A side is equal to 1/2 inch, then we know that's basically, let's draw this out again here. So if this is 1/2, and we know from our diagram up here that generically, if this is 1, this is going to be 2, and this is going to be the square root of 3. So those are our generic values. Well, if this is 1/2, well, 1/2 of 1, so we're taking 1/2 of everything to get this side here. So we have 1/2 times 1 gives us our 1/2 size. So we know we got to take 1/2 of all the other sides. So this side over here, the hypotenuse, or our C side, is going to be 1/2 times 2, which is going to be 2 over 2, which is equal to 1. So our hypotenuse is 1, and then our medium side here, or we've been calling it our B side. So B is going to equal to 1/2 times the square root of 3, which is equal to square root of 3 over 2. So there's our value for the shorter side, and we know the shorter side is already 1/2 that was given. So from this we can make some generalizations. We can say if we draw our 30, 60, 90 triangle, so this is our 30 again, here's our 60, and here's our 90. This is side A, side B, side C. We can make some generalizations. We can say side C, or the hypotenuse, this is also the hypotenuse here. So side C, or the hypotenuse C, is equal to 2 times A. And we can also find side B. Side B here is equal to A times the square root of 3. So there's just some generic terms you can think of here, where B is the medium size, A is the shortest side, and C is the hypotenuse, just like we've done up here when we did the Pythagorean theorem. And so you can generically look at it, C is equal to 2A, and B is equal to A square roots of 3. And once again, the easiest way for me to remember this is you draw out the little triangle, and you think 1, 2, square root of 3. And from that, you can figure it out.